Chapter 10 Light, Mirrors and Lenses, Notes and Summary from Grade 8, Subject Science, Book Curiosity. Introduction. The chapter begins with Meena's visit to a science center where she encounters unusual curved mirrors. In these mirrors, she notices her face appears usually large, her brother looks upside down, and in another, she sees a tiny version of herself. A guide explains that these are not ordinary plane mirrors, but spherical mirrors that are curved inward or outward, which changes how the reflection appears. 10.1 What are spherical mirrors? A shiny metallic spoon acts like a mirror. When you look at the inner curved side of the spoon, the image is inverted. When you look at the outer bulging side of the spoon, the image is erect and smaller in size. Definition. Spherical mirrors are curved mirrors that are shaped like a part of an imaginary hollow glass sphere. Types of spherical mirrors. Concave mirror. A spherical mirror with a reflecting surface that curves inward. So friends, this is the reflecting surface. This is concave mirror and this is its representation. Next, convex mirror. A spherical mirror with a reflecting surface that curves outward. So friends, this is the reflecting surface and this is convex mirror. These mirrors are not made by slicing a hollow sphere, but by grinding and polishing flat glass into a curved surface. A reflective coating on the outer surface makes a concave mirror, while a coating on the inner surface makes a convex mirror. 10.2 What are the characteristics of images formed by spherical mirrors? Unlike plane mirrors, which always form an erect image of the same size, spherical mirrors behave differently. Images in concave mirrors. So this is the concave mirror, this one and this one. When the object is very close to the mirror, the image is erect and enlarged. So this is the object which is close to the concave mirror, then the image is erect and enlarged. When the object is moved further away, the image becomes inverted. So when object is moved further away, the image, this one, becomes inverted. The size of the inverted image is initially enlarged and then gets smaller as the object moves further away. Images in convex mirrors. This one, these are the convex mirrors. The image formed is always erect and diminished, smaller than the object. So the image formed is always erect in convex mirrors and diminished. Diminished means smaller than the object. The size decreases slightly as the object moves further away. Note, lateral inversion, left appearing right, happens in all three types of mirrors. Uses of spherical mirrors. Concave mirrors used as reflectors in torches and vehicle headlights. Dentists use them to get an enlarged view of teeth. They are also the main mirrors used in modern reflecting telescopes. Uses of spherical mirrors. Convex mirrors used as side view mirrors on vehicles because they form erect, smaller images, providing a much wider view of the road behind, like this one. They are also used at road intersections or sharp bends to prevent collisions, like this one, and in large stores to deter theft, like this one, which is called surveillance mirror. This is road safety mirror and this is side view mirror. 10.3 What are the laws of reflection? We use straight lines with arrows called rays to represent the path of light, like this one. The ray falling on the mirror is the incident ray. So this is the incident ray which falls on the mirror, and the ray bouncing back is the reflected ray. So the ray which bounces back is called the reflected ray. The normal is a line drawn at a 90-degree angle to the reflecting surface at the point of incidence. So friends, this is the point of incidence. So when you draw a 90-degree angle, this line is called the normal. The laws of reflection apply to all kinds of mirrors, including plane, concave and convex. First law, the angle of incidence, the angle between the normal and the incident ray. This is I, angle between incident ray and the normal, is always equal to the angle of reflection, the angle between the normal and the reflected ray. So this is the reflected ray and this is the normal. So the angle between reflected ray and normal is called R, which is angle of reflection. Second law, the incident ray, the normal at the point of incidence and the reflected ray all lie in the same plane. So friends, as you can see, this is the incident ray, this is the normal ray and this is the reflected ray. So these three lines lie in the same plane. How spherical mirrors affect parallel light beams? Concave mirrors, they cause multiple parallel reflected beams to get closer together or converge. So friends, as you can see, there are 5 rays which converges at this point. So this is called closing. So here the beam gets close together. This concentrated light can produce enough heat to ignite paper, which is why concave mirrors are used in solar concentrators and solar furnaces. Convex mirrors, this one, they cause multiple parallel reflected beams to spread apart or diverge. So as you can see, when the rays fall on the convex mirror, so these rays gets diverged. So as you can see, the reflected beams spread apart and this is called diverge. 10.4, what is a lens? A lens is a transparent piece of material like glass or plastic that has curved surfaces. Unlike mirrors, light passes through lenses and we see things through them. Types of lenses: convex lens. So this is a convex lens and this is its representation. Thicker at the middle than at the edges. As you can see, this is thicker at the middle than the edges. It is a converging lens because it converges light passing through it. So this is a converging lens. Concave lens, thicker at the edges than at the middle. So thicker at the edges than at the middle. It is a diverging lens because it diverges the light passing through it. Images formed by lenses. So these are the images formed by lenses. Convex lens. If the object is placed close to the lens, the image appears erect and enlarged. As the object moves further away, the image becomes inverted and eventually diminishes in size. So friends, as you can see here, A, convex lens placed at small distance, B, convex lens placed at large distance. Concave lens, this one, an object seen through a concave lens always appears erect and diminished. So as you can see, the object through concave lens appears erect and diminished. Uses of lenses. A common example of a convex lens is a magnifying glass. Lenses are used in eyeglasses, cameras, telescopes and microscopes. The human eye also contains a highly adaptable convex lens. Snapshots summary. An image formed by a concave mirror can be enlarged, diminished or the same size as the object. It can be erect or inverted depending on the distance. An image formed by a convex mirror is always erect and diminished. The two laws of reflection. First, the angle of incidence equals the angle of reflection. Second, the incident ray, normal and reflected ray all lie in the same plane. Laws of reflection are valid for plane, concave and convex mirrors. A concave mirror converges light while a convex mirror diverges it. An image formed by a convex lens can be enlarged, diminished or the same size and can be erect or inverted depending on distance. An image formed by a concave lens is always erect and diminished in size. A convex lens converges light while a concave lens diverges it. So friends, we have completed notes and summary of chapter 10, light, mirrors and lenses. We will do all the question answers of this chapter in a separate video. If you like the video, kindly like, hype the video and share it with your friends. Also subscribe to my channel and press the bell icon to receive new video notifications. We will meet in the next video. Thank you for watching.